question 4b, we're working with that same triangle that we had in the last question. So we have 5, 12, and 13, and we have to approximate the acute angles in this triangle. So I'm just going to draw us a triangle, a right triangle, that we can use. So aren't you impressed with my super straight lines? Probably not. Okay, so there's our right triangle. Not perfect, but it'll do. Okay, now we have a 5 for a side, we have a 12 for a side, and we have a hypotenuse of 13. So what we need to do is we need to estimate these two angles right here. Okay, so we'll name one of them X and we'll name one of them Y. So if we want to find X first, okay, that's this angle down here. So this is where our theta is. And from here we go opposite. This is our opposite side. This is our hypotenuse. This is our adjacent. So it doesn't really matter which one of these three we pick. We can do the opposite over the hypotenuse. So we have the sine, or the opposite over the hypotenuse, is 12 over 13. And if we divide 12 by 13, it's going to be really close to 1. 0.923. So this is equal to 0.923. Now we have to make sure that we look in the correct column. So we're looking in the opposite hypotenuse because those are the two that we used for our ratio. And we're looking for approximately 923. Now it's really, really close to this one right here. So we can call this like maybe 67, 68. And so if one of those is 67, whoops, if one of those is 67, then the other one has to be 23 because they have to add up to 90 degrees. These three angles all have to add up to 180. So if this is 90, then these other two have to take up that remaining 90 degrees. So we could say like 67 and 23, maybe 68 and 22, somewhere around in there.